All right. So we just finished, doing this part up here, which was basically doing the normal regression way. So we're using equations. This is going to be a slightly different way. This is using a method called gradient descent. So what we're trying to do is minimize a function well, hopefully we can find a minima for, right? So what are we trying to minimize? We're trying to minimize that squared error function. Now, it turns out that the squared error function is actually not the best function for us to minimize. So what we're actually going to do is we're going to minimize a slightly different function, which is called the mean squared error function. All this means is that instead of it being just the sum of the squares, what we're going to do is we're actually going to divide by n, right? The number of data values that we have, right? The number of x, y pairs that we have. So when we actually go to run, to run this, we're going to minimize the mean squared error rather than just the regular squared error function. It turns out that this is a little bit better. It's a little bit better function to minimize for us, but for what we're about to do. Right, so the data importing is going to be pretty much the exact same, right? I still want to use the exact same data values that I had for the one up there. So what I want to do here, now I've just imported it. I basically just copied from what I had above. So now what I want to do is do initialization. So what am I going to initialize? Well, I'm going to initialize some variables. Now, right, what I want eventually is the B0, the B1. What am I going to need? Well, I'm going to need like a learning rate thing. I'll just call it L. I want to set this to be pretty small, not tiny, but 0.00, maybe 0.001. We can try it here. Maybe we like it, maybe we don't like it. We'll figure it out. The next thing we want to do, maybe we want to initialize what our B values are. So maybe I could say B0 is, well, I can make them both 1. It doesn't really matter what they are. It'll sort itself out. Let's see. The other things we're going to want in this case, so I've got learning rate, I've got the B's here. I might want to set a max number of iterations, so I'm going to call it max it. And I'm going to actually make this quite large. Make it, is it 10,000? I could do 100,000, sure. 10,000, 100,000, something like that. All right, so what am I going to do now? Well, what I'm going to do is I'm going to take the derivative of the mean squared error function, right? Which is, like I said, that's the function we're actually going to minimize. I mean, if we find a function that if we find values that minimize that, it actually minimizes the squared error function as well. So since that's, now we're just dividing a number by n, right? So let's see. Right, I'm just going to go in the range to max it. Now I'm not gonna worry too much about what I'm doing here, as far as like checking that I'm less than some numbers, right? But here we go. So what I want to do now is I want to just start updating things, right? I'm going to call something y hat. So what does y hat equal? Well, it just equals my B0 plus the B1 times the x values that I have, right? So that's my y hat value. Right, so I have that. In the for loop, I'm computing y hat, and then I'm saying that B0, well, that's just going to be equal to whatever it was before, and I'm going to do minus the derivative times this rate, right? This basically the step size, if you want. Yeah. So Now it turns out the derivative for b0 is just negative 2 over n, right, times the y minus y hat. So if I do that, what I get is plus 2 divided by n times, I'm just going to do y, right? So these are the y values minus the y hat values. And what is b1? Well, b1 is very similar to this, right? But instead of just negative 2 over n times y hat, it's negative 2 over n times x times y minus y hat. So here I'm just going to do the same thing. So plus 2 over n. Here I've got times this x times x minus, I'm sorry, y minus y hat. Okay. Oh. And now I'm not quite done. So instead of just doing these, right, I actually need to sum all of these up. So I'm going to write a sum right here and a sum right there. And what do I want to do? I want to multiply these by L, right, my time step values. Or my, just my step size value. Most of the time this is referred to as a learning rate. Okay, and I just let this run for a very long time, some 10,000 iterations or so. And there we go. That's it. This is it, right? Each time what it's going to do is it's just going to go and go in whatever direction is appropriate, right? And it's going to take very small steps, and eventually, hopefully, it's going to get me down to a minimum value for the B0 and the B1. And let's see if we're close. I don't know. Right? Maybe we're very close. Maybe we're not. We may have made a mistake, so we'll have to go back in and check. So, well, I've definitely made a mistake. Oh, I see what the mistake is. Here I didn't put a multiplication here. Okay. Okay. Well, this isn't quite what we expect. We could probably do a little better. Let's see. Allowing it to run for a little longer actually gives me a better result. Yeah, so this is pretty much what we expect, right? So I let it go through 100,000 iterations. That's fine. Here I have 428 plus the 17. So this is very, very close to actually what we achieved over here. And so there we go. I guess that's another method for solving this.